My name is Daniel Schwartzberg and I'm proud to be able to introduce to you our satellite radar demo, which proves the viability of an innovative architecture for radar integration in the automotive industry. Cars today have what we call edge processing radars, meaning raw data processing is done within each individual radar and low bandwidth data is sent along to an ECU. One drawback here is that processing can account only for data from one radar to make decisions. Another drawback is that each individual radar requires its own processor and power supply, driving up the total system cost. Satellite architectures being proposed in the industry would move processing to a centralized compute unit, which would require raw data flowing through high bandwidth links. This would allow for decision-making to account for various radars, as well as other sensor types, thus facilitating the industry trend towards sensor fusion and centralized processing. Removing the processors from the radars also opens up the opportunity to remotely power the radars, which contributes to the overall reduction in total system cost. Essential to this approach is the need to tunnel complex control signals at high speeds between the host processor and the remote sensor, and Valens chipsets enable this. Let's see how this works. On one end of our demo, we have our off-the-shelf frequency-modulated continuous wave radar connected to a module containing the Valens VA7000 serializer chip. CSI-2 data from this radar is tunneled over the channel for distances of 15 meters over a coax cable or 10 meters over SDP or UTP with up to 4 inline connectors. As you can see here, in this case we have a 10-meter long UTP cable with 3 inline connectors. You'll also notice that the radar is being powered from the far side over the same cable. On the other side of the link, we have our Valens VA7044 deserializer chip connected to an NVIDIA SoC. On this display, you can see the resulting process data. By removing the MCU, the radar can be physically smaller, less expensive and can consume less power. And with power being supplied over the same cable as the data, there is no need for a dedicated power connector. The VA7000 chipsets, which have an ASIL-B functional safety rating, also support the tunneling of SPI for fast chirp control and the distribution of extremely accurate reference clocks and frame synchronization pulses. A shift to this satellite architecture would lead to sensor fusion, which could help the industry reach the next stages of autonomous driving. This solution leverages the Valens VA7000 family, the first MIPI A-PHY standard compliant chipsets on the market, providing reliable, long-distance, high-bandwidth sensor connectivity.